Hello everyone, welcome back to our channel. I am Josh, and together with Red, Kaleel, John, Berth, Justin, and Loruelle, we will be talking about the manufacturing of cement in today's video. By the way, we are the group 2 and we will be discussing about the fifth topic in our course. So, in today's video, we will talk about the different phases of manufacturing a cement, which is widely used in construction, construction firms, or even doing tasks where it is required. So, the topic outlines would revolve around the introduction, the phases of the manufacturing, specifically the raw material extraction, the proportioning, blending, and grinding, the preheating of raw materials, the kiln phase, the cooling and final grinding, and then packaging and shipping. So we would like to also talk about the flowchart of production of cement so that you'd have a visualization of what's really happening in the upon the manufacturing of the cement as well. We would also talk about the environmental impact of its production, since it's also a vital topic to discuss because there are certain issues that comes up when we are talking about uh, the manufacturing of certain products. So no no products in the world, I think, are exempted with this topic. Hence, we would try to talk about it. So let's head into our introduction. Cement is a basic ingredient of construction and the most widely used of construction material. It is a very critical ingredient because only cement has the ability of enhancing viscosity of concrete, which in returns provides the better locking of sand and gravel together in a concrete mix. So, when you try to imagine all the buildings around you, it's impossible to think that cement wouldn't be involved in such uh, activities like construction. Even if your house could be built for around the lightweight materials, some some people do use cement as their primary ingredient for enhancing the foundation of the structure. It is sturdy, it is very durable, and it stands with the test of time. With the proper maintenance, cement would last way longer, and you know, compared to the light materials which are prone to degradation because of the termites, might say, with proper maintenance, cement can last for even longer. As you can see, structures from around the city, like the theaters, are still present right now and are being used, like what's in the structure beside the Save More in the Capistrano Street. As you can see, the building is still standing tall despite of its old age because cement is used there. Concrete makes it sturdier, and with proper maintenance, it will last even longer. So, there are two types of processing the cement manufacturing. We have the wet processing and the dry processing. So let's talk about one of them each. So the dry processing, a dry process is minerals are dry ground to form a powder-like substance. So your raw materials are most likely going to the blender and then forms this substance, powder-like substance. So it is that way. All the raw materials are easily mixed. You see, it becomes a somewhat homogeneous mixture once it is converted into a powder-like substance. So mixing of raw materials in a dry state are done in blenders, and that's why the cost of production of a dry processing cement manufacturing is less compared to its wet processing counterpart. So, so in dry processing, the size of the kiln needed for manufacturing of cement is smaller compared to its wet processing counterpart, since the raw material is already dry and does not require even further drying, since as mentioned it's already dry. And as previously mentioned also, is that the cost of production is less. However, it has a caveat of having a much more costlier capital cost, since a lot of blenders should be involved in this type of processing. Uh, you will not use water compared to the wet processing. So all these raw materials should be should undergo blenders to achieve the powder-like substance before they're getting mixed into each other. So always remember, the dry processing has a lesser cost of production, but has a more capital cost. To further add, dry processing dry processing's cost of production is even fortified with the evidence that the amount of fuel or the coal that used by the kiln in production is rated by 100 kilograms of coal per tons of cement. So if we compare that to the dry processing, which is rated at 350 kilograms of coal per tons of cement, that solidifies the claim that the dry processing's cost of production is way lesser. So let's talk about the wet processing. Okay, in wet processing, minerals are wet ground, and they achieve this form by adding water, and then they are called slurry, and then they're dried. So the water in the wet processing consists of 35 to 50%. So that's a lot, right? So since they are wet, by in the word, the size of kiln needed for manufacturing of this cement is bigger, since they need to be dried once they exit the kiln. So although the the cost of production is way more expensive than the dry processing, the raw materials can be easily mixed since they are already wet enough. The capital cost for the wet processing for the cement is comparatively lower than the dry processing. So that is for the types of processing of the cement. So let's talk about the first phase of manufacturing a cement. The first phase is called the raw material extraction. So in the raw material extraction, calcium, silicon, iron, and aluminum are all used as basic components in the cement. Limestone, clay, and sand are examples of such basic materials. So calcium is found in limestones. It's mixed with sand and clay in significantly lesser amounts. Silicon, iron, and aluminum are all met by sand and clay. So this calcium that is required to be integrated in the cement's manufacturing, it can be found in calcium carbonate. So calcium carbonates or limestones contain these calcium needed. And then other elements such as silicon and iron can be found in your sand and clay. So if you notice sands in the beaches, in the local beaches here in Cagayan de Oro, you can see those black black residue. If you can observe that, those are iron fillings. When you drop a magnet into them, they are easily attracted to the magnetic field that the iron magnets has. So clay, on the other hand, are mined. It's found in several areas like what I've seen in Bukidnon. They are particularly red in color, so we'll get to know about them in the following slides. So, uh, this is the limestone, which is the calcium carbonate, and this is what it looks like. So as you can see, they are uh, bigger in picture, and that's why they are needed to be grinded in the blenders to become the powder-like substance that they need to be in. The processing requires numerous amounts of blenders for different raw materials that are needed for manufacturing of the cement. So they need to achieve a certain amount of sizes before they are going to be processed further into the steps. So these are the limestones, and you can see here that these are the sand and the clay. So as you can see, sand has a lot of smaller grains that could contain the iron and silicon. Silicons are particularly created from melting these sand in hot furnaces in order to achieve that liquid form. And then clay, on the other hand, are these red-like soil. So clay can be found on the deeper portions of the soil, and in quarries where you have those kinds of equipment, I think it's not impossible to get these clay into processing. So, in most cases, cement facilities are located near a limestone quarry. This saves money on petrol and makes cement more cost effective. The raw materials are excavated from the quarry and transferred to the cement factory by conveyor belt. So, this is the best way to make the cement more cost effective, cheaper for the consumers as well. They build their factories near these quarries so that the loading of those raw materials is way cheaper, easier, and costs less. So also with having a less time traveling those raw materials into the manufacturing site, they can cut time for the traveling if they are far away from the quarry, and then in result they could produce even more cement and can drive those profits high up. So the extraction of raw materials and crushing of materials are all done near the quarry. So this is an example of a cement manufacturing plant located in Nova Scotia, Canada. It's Lafarge Canada Incorporated, and as you can see, the cement manufacturing plant is over here, and then the quarry where its raw materials are excavated from are here. So that is a cost-effective plan of manufacturing a cement. So lesser petrol means that they have lesser budget to spend on those petrol to drive those trucks to deliver the raw materials to the manufacturing site. Instead, they just use conveyor belts to deliver those processed, sort of grinded raw materials. So let's get to know the other raw materials that are needed in manufacturing the cement. All these raw materials are brought from other sources, since the manufacturing plant only needs a little amount of them. So here's the first one. It's shale, and shale is a fine-grained sedimentary rock that is readily split into thin parallel layers and develops from the compaction of silt and clay-sized mineral particles. So shale contains the other chemicals that would be necessary for the cement. Those elements will be discussed further in the uh, further phases of this today's topic report. So that is shale. We also have here fly ash. So fly ash is a coal-fired power and steam generating plants create fly ash. So from steam generating plants, they create this residue. So coal is often crushed and pushed into the boiler's combustion chamber with air, where it burns instantly, creating heat and molten mineral residue, resulting into this raw material that is used as well in manufacturing cement. So we also have this other raw material in mill scale. Mill scale is one of waste materials which is produced as a result of hot rolling steel in all steel companies. So on the other hand, mill scale is also considered a rich iron source with minimum impurities. So we all know the importance of having a minimum impurity in a material. Hence, mill scale could also be a good source for iron in the cement manufacturing. And last but not the least, we have this bauxite. Bauxite is an important mineral in the mining industry. Globally, bauxite is the primary source of aluminum ore and mainly major industry in many countries, including China, Australia, and Brazil. So it's in the description already that the bauxite is a vital part of this manufacturing, since it is also a primary source of aluminum. So it is mined as well, but you don't need that much aluminum in the cement. Uh, so only a few portions of this material is needed. Hence, it's not really it's not really mined primarily in the quarry. It's more likely brought from the other sources. So, in phase one raw material extraction, so before transportation of raw materials to the cement plant, large size rocks are crushed into smaller size rocks with the help of crusher at quarry. So crusher reduces the size of large rocks to the size of gravels. So between 9.5 millimeters and 37.55 millimeters in diameter. So this is what I've been talking about before transporting the raw materials to the cement manufacturing plant. They undergo crushers as huge as this. This is the Savage Stone Quarry. They have this kind of blender and a crusher, and then they crush these huge raw materials such as these limestones into acceptable sizes like the 9.5 millimeters and 37.5 millimeters in diameter. So I think that would conclude the first phase of cement manufacturing. And let's move over to my colleagues who will discuss the second phase of the cement manufacturing.
Now we'll go on phase 2, which is the proportioning, blending, and grinding of cement. The raw materials from quarry are now routed in plant laboratories where they are analyzed and proper proportioning of limestone and clay are making possible before the beginning of grinding. By altering the amount of any ingredient during cement production, one can achieve the desired cement quality. So magdepende din na sa company no kung na sila ay desired characteristic na gusto nila makita sila cement. So dila nila pwede i-alter nila ang proportions per component sa ilang cement. It is always desirable to use the best cement in constructions. Therefore, the properties of cement must be investigated. Although desirable cement properties may vary depending on the type of construction, generally, good cement possesses following properties. It provides strength to masonry, stiffens or hardens early, possesses good plasticity, an excellent building material, easily workable, and has a good moisture resistance. It is also important to note that cement is not synonymous with concrete. So, mo lang visualization. Mo yung cement, mo ang concrete. So, first is the lime. It's the most important ingredient of cement. The cement contains 60 to 67% of lime. It is obtained from limestone, chalk, shale, etc. The presence of lime in a sufficient quantity is required to form silicates and aluminates of calcium. Deficiency in lime reduces the strength of property to the cement and causes the cement to set quickly. Excess lime makes cement unsound and causes the cement to expand and disintegrate. Second component is silica or silicon dioxide, which is the second largest quantity of cement ingredient, which is about 17 to 25%. Silica can be obtained from sand, argillaceous rocks, and etc. Sufficient quantity of silica helps for the formation of dicalcium and tricalcium silicates, which imparts strength to the cement. Excess silica in cement will increase the strength of cement, but at the same time, setting time for cement is also increased. The third ingredient is alumina, which is present in the form of aluminum oxide, which is about 3 to 8% of the whole structure, and is obtained from bauxite, alumina, contained clay, and etc. Alumina imparts quick setting property to the cement. Clinkering temperature is lowered by the presence of requisite quantity of alumina, and excessive alumina weakens the cement. The fourth ingredient is magnesia. So cement contains magnesia or magnesium oxide in a range of 0.1 to 3%. So gamay education, no? Gamay na kaya ang kailangan. And magnesia in cement in small quantities imparts hardness and color to the cement. Excessive magnesia will reduce the strength of the cement. The fifth component is iron oxide, which ranges from 0.5 to 6%, which is contained from fly ash, iron ore, scrap iron, etc. Iron oxide imparts color to the cement. It acts as a flux, and at a very high temperature, it imparts to the chemical reaction with calcium and aluminum to form tricalcium aluminoferrite. So this tricalcium aluminoferrite imparts hardness and strength to the cement. So ga-impart siya og color and strength sa cement ang kaning iron oxide. The sixth ingredient or component is a calcium sulfate, which is present in the form of gypsum in a cement. It is found together with limestone, and it ranges from 1 to 3%, which it slows down or retards the setting action of cement. The seventh component is the sulfur trioxide. The sulfur or sulfur trioxide in cement is about 1 to 3% also, and excessive sulfur trioxide causes the cement to be unsound. And the last ingredient component is the alkaline, the alkalis. Like soda and potash are present in cement, which normally ranges from 0.1 to 1%. So muna pinakagamay yung range no sa whole structure sa cement. So during manufacturing process of cement, most of the alkalis are carried away by the flue gases at the time of heating. Hence, cement contains very small quantities of alkalis in it. If alkalis content is more than 1%, it will cause several problems like alkali aggregate reaction, efflorescence, staining, etc. Now, cement plant grind the raw mix with the help of heavy wheel type rollers and rotating table. Rotating table rotates continuously under the roller and brought the raw mix in contact with the roller. Roller crushes the material to a fine powder and finishes the job. Raw mix is stored in a pre-homogenization pile after grinding raw mix to fine powder.
Good day, everyone. Good day, sir. My name is Reydel, and I'm here to discuss about the third phase of the cement manufacturing, which is preheating raw materials. After final grinding, the material is ready to face the preheating chamber. Preheating chamber consists of series of vertical cyclone from where the raw material passes before facing the kiln. Preheating chamber utilizes the emitting hot gases from kiln. Preheating of the material saves them energy and make plant environmentally friendly. And we will see what the preheating raw materials process look like. Uh, when the raw material enters these kind of machines, which is called the preheating cyclone system. A cyclone separator or a cyclone system is a static machine which is separates something, separates from liquid to gas or anything that would like to separate, include that uses gravity and the vertex inside the cyclone, um, which is the lime and the calciner limestone will face the hot air from the kiln, and after it face the hot air, the lime will go through the left side of the rotary kiln, no? Preheating of raw material vertical cyclone. And next slide will be the detailed explanation or detailed description of this process, no? Currently, most cement kilns operate in conjunction with the preheating tower. No, as you see in this diagram, na tapad ra ang cyclone and most cement manufacturing will have a kiln, and besides a kiln, kanang tapad sa kiln is the cyclone, which is kana dia ang preheating sa mga raw materials, no, which is responsible from removing the residual moisture. So, di ba? Naagi mga moisture usahay ang mga butang. So, need na to kuhaon ang moisture so that ang ang 99% ana materials na ang or 100% ana na lang katong bone dried nga sini nga material na lang ang which is ang katong mga raw materials, which is lime, katong calciner and limestone and other materials. Muna atong gusto from the raw mill and initiating the decarbonization process of limestone. The preheaters are constituted by a series of cyclones. Since akong thesis pod is kanang surround pod og cyclone, which is among thesis is pyrolysis of plastic, and this machine system needs a separation of char and the syngas or the plastic gas, no, i-separate na to ang charcoal o katong gas. So need na mo ang cyclone separator, which is ako ang thesis muna ako ang gi-study, and sa ako pagsabot sa cyclone separator, the more cyclone separator sa naa sa machine, it will increases the efficiency of separation or separation of solid particles from the stream of gases, no? It uses, no, it gi-advantage niya ang pag-use sa gravity, no, ang og ang centrifugal force, which is motuyok ang mga particles or gikan sa sani sa katong mga raw materials, ang katong bugat moubos, ang katong stream mo taas, hot stream gikan sa kiln, no, installed vertically in series and interlaced with each other through chambers. No, makita man nato sa diagram dere na inana vertically and alternating yang pag-use. And the more cyclone separator again sa isa ka machine, it increases the efficiency of separation of solid materials to the stream or gases. No, the chambers are used to effect the thermal exchange between the cold particles, approximately 60 Celsius of the kiln raw meal feed, and the hot gases, approximately 1110 Celsius of the kiln. Uh, through the through the sequence of cyclones, the hot gases coming from the kiln flow against the current with the raw materials that falls rather by the gravity. No, as I said earlier, na uh, this cyclone will no ang process aning cyclone is that the heavier particles will fall, and with the help of kaning gadiagonal nga cone na cone, it will help na mo fall mo mahulog gid ang ano no ang solid nga particles, and the hot gas or stream mo atos taas. So mo na ang murag function yun sa cyclone separator. It is to separate, and advantage niya is there is no moving parts or elements sa kanang walay mga machine, walay mga gears and such. Static ra siya machine. Ang ga-move ra is ang particle o ang gas or a stream no sa cyclone. At the end of the process, the raw material inputs the kiln with a temperature closest to 870 Celsius as soon as the gases are suctioned with a temperature close to 370 Celsius on average. As it mixes with the gas flow, heat transfer and mass transfer occur. So as we see, no, kung naay involved nga gas flow and heat transfer and mass transfer, since naman ni siya closed nga system, dahil gadil siya nga I mean open system, since naman kasulod o gawas og mass, since so open system siya, and napod mass transfer, since open system, it exchanges mass from the environment, no, as we recall it sa ato ang thermodynamics nga 1. And that is all for the phase 3, which is the raw material preheating of raw material. Thank you, everyone. Thank you so much.
So now for the fourth phase of cement production. This phase utilizes the use of device called a rotary kiln or rotary furnace. Rotary kiln is a pyroprocessing device used to heat materials to high temperatures in a continuous process. The device can cater this continuous process by receiving the raw materials from the silo or from the preheating chambers and provide it the required heat to produce its byproducts. This can be done without any interventions. The kiln body is a cylinder vessel, as you can see in the image provided, with a certain degree of tilt to the horizontal level. So this tilt helps the raw materials coming from the input of the device reach the output with only the use of rotary motion. This is a diagram of the rotary kiln. As you can see, the device is tilted with a heat source coming from the other end. The upper end of the tilted cylinder is where raw materials is being fed, and the device has a drive gear which provides rotary motion to the entire device. And as the entire device rotates, the feed material goes down up to the bottom end, which is the output for the clinker or the output material of this device. So the feed material is being fed, reaching the inner or the first stage of this heating process. It heats up to 1000 degrees Celsius, as you can see above this diagram. Then as the device rotates, it transfers to the second phase or second stage, with it can reach up to 1300 degrees Celsius. And when it reaches the third stage of this heating process, it can reach a temperature of up to 1450 degrees Celsius. Then it will slowly cool down as it reaches to the other end or the bottom end. So while the drive gear rotates the kiln or the furnace, it also mixes these materials, making the perfect byproduct of this process, which is called the clinker. So the main function of the rotary kiln is to convert the raw materials into a clinker through a process of purification called calcination. So yes, the calcination is a thermal process that which cleanses or purifies the raw materials coming from the input of the furnace. So as it reaches the end, it will become cleaner and produces a clinker. So after the calcination is completed, the clinker will be pre-cooled in the chamber and then be sent to the cooler for further cooling. So how does this cooling of this byproduct, the clinker, is done? It will be discussed by the next reporter.
Phase 5 will be cooling and final grinding. After the kiln phase, the clinker goes through the clinker cooler. This machine cools the clinker using a continuous stream of cool air. The clinker must be cooled down to around 200 Celsius to be grinded and for further storage. Optionally, the released heat by the clinkers can be reused by recirculating it back to the kiln. This process is shown in this diagram. The clinkers are laid out into a moving grate as it exits the kiln. It is then cooled down by a continuous stream of cool air from below. The hot air is then exhausted at the top or recirculated back to the kiln. After the cooling phase, the clinkers are loaded into a ball mill. The ball mill machine works by using steel balls to grind materials. It works on the principle of impact and attrition. Size reduction is done by the impact as the balls drop from near the top of the shell. Here, the balls will tumble and crush the clinkers into a very fine powder. Gypsum is then added to the mix in small percentages. The resulting powder is then considered as cement. Finally, the cement is then packed and shipped. The cement is directly conveyed to the silos for temporary storage. A small amount of total cement produced will be packed in bags measured in kilograms ranging from 20 to 40 kilograms for specific use cases. The remaining cement is shipped in bulk quantities by means of trucks, rails, and ships.
To sum it all up, this is a flow chart for the production of cement. As mentioned earlier, it can be done in two ways, wet process or dry process. So it's either clay being purified and mixed with 35 to 50% of water, resulting to a slurry, or limestone being crushed and pulverized, resulting to a powder or what you call a meal. Um, at first, first, it's either a wash mill for a wet process or a raw mill for a dry process. The slurry or the meal then goes to an electrostatic precipitator, wet or dry, to filter out fine particles with the use of the force of an induced electrostatic charge. The raw slurry or raw meal is then stored in the silos where they are blended and proportioned before the preheating stage. So we have these preheaters. These preheaters utilize the hot gases from the kiln. As we all know, this allows the material to already be in a high temperature before entering the kiln, reducing the amount of coal burned as well as the carbon emitted. Kiln, being the heart of the cement production, is basically a giant rotating furnace that heats up from the exit side um, by the use of coal or natural gas. It heats up the material, causing a series of chemical reactions which form your calcium silicates and calcium aluminates, which are the primary constituents of cement. As the material exits the kiln, they form into this um, hard gray balls called clinker and are cooled by air. The, rele- the released heat by clinker is also recirculated back into the kiln to save more energy. Then the clinker is stored in a silo. Then it is crushed into a very fine powder in a cement mill while also adding a small amount of gypsum to help control the setting of the cement. Lastly, they're conveyed into cement silos where they're pre-stored for packing and delivery. So, quick rundown on the main differences of wet process and dry process. So basically, wet process needs a bigger kiln as it accommodates a slurry, resulting to a higher fuel consumption than dry process. Wet process can easily be mixed as its material has water, so a better homogeneous material can be obtained compared to the dry mixing of dry process. Wet process has higher cost of production because of the use of water and it needs more amount of fuel. And capital cost of wet process is actually comparatively less as it doesn't have these huge blenders that the dry process has. So for the environmental impact, as a material that creates the majority of the world's bridges, roads, dams, and construction, concrete releases an extreme amount of carbon dioxide each year. It's the highest consumed product on Earth besides water. Until the overall emissions are cut worldwide, the environment will continue to be polluted with over 4 billion tons of carbon dioxide annually due to this industry. Now, to give some context why I am talking about concrete instead of cement, as they are two different things. Concrete is constructed using cement mixed with an aggregate. So these aggregates are sourced from a local body of water and crushed in a natural procedure. Now, that process releases nearly no carbon emission. The cement is the true problem when it comes to carbon footprint. So this makes so the cement process is the sole reason why why the concrete industry contributes to contributes up to 8% of the overall global emissions by category. Now, there are actually some solutions that can be considered to fight this problem. So, one of them is the first rather being is the change in the industry, and it can only be possible with the participation of the leading global cement companies or concrete companies to be able to make a significant change to reduce their environmental footprint. Next is carbon valorization. This is the conversion of waste carbon dioxide into valuable products such as feedstocks or fuel, which can actually be sold. Next is the use of green cement technology. One example is um, taking the emitted carbon from from the kiln and substituting that mixture in the open spaces of the previously made cement. Then to cure the product, they put it in a room with carbon dioxide instead of water, which overall reduces carbon emissions in cement production by 70%. This mixture takes less time to cure, is sturdier, and requires less energy to produce, which results in a more cost effective and effective way to create cement. And lastly, carbon sequestration. Carbon sequestration is the natural or the artificial process of removing carbon dioxide in the atmosphere. So it's either the use of like biomass or uh, geological sequestration or man-made carbon neutral technologies. So that would be all for our report. Thank you very much for listening.